Hello, this is Mr. Collier, and today we're solving some inequalities. Firstly, we're going to graph a few inequalities. So here we have x is less than negative 2. So x could be any number that's less than negative 2, so it could be, for example, could be negative 3. Okay, but there's many possibilities. It could be negative 4, it could be negative 5, it could be negative 4.5, negative 3.5, negative 2.5, and all the fractions in between. So x could be any of these numbers and on towards negative infinity. So to graph the solution or the inequality x is less than negative 2, you can just draw a line, a solid line with an arrow going from negative 2 off to negative infinity. Now, is negative 2 included? No, x cannot be negative 2 because then it wouldn't be less than negative 2. So to indicate that on the graph, we make a hollow dot. That means the negative 2 is not included. Number less than negative 2, like negative 2.000001, is included, but not negative 2, so we make a hollow dot. And that's how you graph this inequality. In the next example, we've got x is greater than or equal to 1. So x could be 2, that's greater than 1. Could be 3, could be 4, could be 5, could be all the fractions in between, off to infinity. So you can draw a solid line. And at x equals 1, well, x can be equal to 1. So we make a solid dot here. Okay, that's the main difference between these two graphs. This one has a hollow dot because there's no equal to sign. This one has a solid dot because it's greater than or equal to. So this graph indicates all the possible solutions to x is greater than 1. Okay, let's look at solving now, solving some inequalities. On this inequality, we've got 14 less than or equal to p is p plus 2. So very similar to solving equations. You need to isolate the p, so we're going to subtract p from both sides, or subtract 2 from both sides rather. You get 12 is less than or equal to p, which you can also write as p is greater than or equal to 12, if that helps you out. Okay, so p is greater than or equal to 12, so I'm going to draw a number line here. I'm mainly interested in the number 12, so I can start there maybe. 12, 13, 14, and so on, 11, 10, and so on that way. Okay, I'll have to use a different color now, I guess. So p is greater than or equal to 12, so that's going to be a solid dot because 12 is included, and greater than 12 is over this way. It could be all these points. So we make a solid line with an arrow, goes on to infinity, so that's the solution. P is greater than or equal to 12. In the next example, very similar to solving equations. If you see n divided by 7, you're going to have to multiply both sides by 7. And we're going to get negative 70 is greater than n. Or you can write that as n is less than negative 70. So if we draw a number line, we're mainly interested in the number negative 70, so let's put that in the middle. But now be careful here, one larger than negative 70 is going to be negative 69. Then we got negative 68, and that's negative 71, negative 72. Okay, so n is less than negative 70. So at negative, it can't be equal to negative 70, so we use a hollow dot. Negative 70 is not included in the solution set. And n is less than negative 70, it's got to go this way. All numbers less than negative 70 go that way, and that's how we graph the solution to the inequality. Okay, next. A little bit more difficult ones here. Okay, so there's actually two ways you can solve this one. You can use the distributive property and multiply, and then you get two steps left, or you could divide both sides by negative 4. Let's do the distributive property and multiply that out. So you're going to get negative 4x. This is a negative 4 times a positive 2 gives you a negative 8. Is greater than or equal to 60. I don't have much room there, that's fine. I will add 8 to both sides. Okay, adding 8 to both sides, I get negative 4x is greater than or equal to 68. Okay, here we're going to divide by negative 4. Now here is the tricky part, and this is the only thing that's different about solving inequalities and solving equations. Let's take a look at a different example here off on the side. Let's say we got the statement 4 is less than 8. Of course that's true, 4 is less than 8. Let's see what happens when we divide by negative 2, both sides by negative 2. If we divide both sides by negative 2, we're going to get negative 2 is less than negative 4. Now that is not true. Okay, it's actually the opposite. Negative 2 is greater than negative 4, so this needs to be greater than. And this is what happens when we divide or multiply by a negative number, we have to flip the inequality sign. Okay, so that's only when you're multiplying or dividing by a negative number, you flip the inequality. So here, back to my example, when I divide by negative 4, you're going to get x, and you have to flip the inequality. That's going to be less than or equal to, and it's going to be negative 17. So x is less than or equal to negative 17 is our solution. Okay, so actually I want to graph that on a new line here. Okay, negative 17 is what we're interested in. That's negative 16 and so on. Negative 18, so 17 is included, so we use a solid dot. It's less than negative 17, so it's going to go this way. There's your solution. Okay, next example. We've got this expression is less than 1. We can get rid of the 6 right away by multiplying both sides by 6. These 6's will cancel. We get, so let's write it over here. We get negative 3 plus x is less than 6. And then one more step, we're going to add 3 to both sides. We get x is less than 9. So x is less than 9, we'll put a 9 there, 10, 11, 8, 7. And graphing, 9 is not included. Okay, 9 is not included, is less than 9, so we need a hollow dot. Less than 9 goes this way. Okay, so there you go, there's your solution.